My name is Mohamed Tabal, and I am a software developer. I've been a full stack engineer at Uplearn for the past 3 years. Prior to that, I was a petroleum and mechanical engineer. Decided, you know what, mechanical engineering was not my cup of tea, and software engineering was something I really enjoyed and I felt was really fun. So I started pursuing it, and here we are today. Today I'm going to be introducing you guys to IAC, Infrastructure as Code. I believe, a bunch of you are probably familiar with it, so take this as sort of like a refresher, kind of a recap. And for those that are not familiar, this should be like a good welcome to the journey of Infrastructure as Code. And we're going to use Terraform to kind of use that as an example for IAC. So let's get straight into it. I think the best way to understand anything is by starting off with the pure definition of IAC. So IAC is a way of managing IT infrastructure by using code to define and automate the provisioning, the deployment, and the management of infrastructure resources. So that's what the pure definition is. But maybe to help a bit with understanding it, let's use a real-life example. So over here, we've got Steve the Stickman. Now, Steve the Stickman enjoys gardening a lot. That's his hobby. He loves watering the lawn. So he wakes up very early in the morning, turns on his sprinklers, waits about an hour, 2 hours, turns them off, and that's sort of what he has to do to keep his garden really nice. The problem is, though, one day, Steve the Stickman decides, hey, I want to go on holiday, but I've got nobody to take care of my garden. So what do? So luckily for Steve the Stickman, he is not only a stickman, but he's also Steve the software developer. And so he writes a Python script that he uses to to automatically turn on the sprinklers every morning and turn them off by themselves. Now, this is sort of a great example of how infrastructure as code can be used in real life. Now, this specific analogy, however, doesn't really portray the full picture of infrastructure as code because it has the key points of automation and deployment, but it lacks the provisioning because we don't live in the matrix and you can't just provision some sprinklers out of thin air. So let's find an example that is actually perfect. And the way we can do that is using Terraform to create some AWS S3 buckets. All right. So for those that are not familiar, AWS has a service called S3, stands for Simple Object Solution, Simple Storage Solution, Simple Storage Service. And essentially, it's just a bunch of folders that live in the cloud that have a bunch of files attached to them. They're called buckets and objects. And similar to Steve, I also have a hobby, except my hobby is ducklings. I like taking pictures of ducklings. So I have a bunch of pictures of ducklings, but I want to store them in my S3 bucket. But I want to do this in a nice automation sort of way. And so let's get cracking. Let's get into that. So first, I have some Terraform code. Very simple. All I'm doing here is I'm telling Terraform that I want to start using AWS. So I've given it a block with a provider saying, hey, my provider is AWS. I've given it some sort of login details, otherwise known as the access key and the secret key, and the region that I want to deploy my work into. Very simple. Next, I'm just going to run Terraform init. All that's going to do is it's going to tell Terraform, hey, the provider is AWS. It's not Google. It's not Azure. It's not anything like that. It's AWS. So it just goes through that, creates a log file. Very simple. As you can see there, it's updated it with some metadata, nothing we really care about. It's not super important. The main TF is really where, the bit that we really care about. So now let's add, that's a bit of details that I've rubbed out, but the bucket, that's what we want. We want to create a bucket where I can store my ducklings called CODECON hobbies. All it takes is literally 3 lines of code, and what that's going to do is we're going to run a Terraform plan. So Terraform has this feature called plan and apply. So before I want to make any changes, add anything to AWS, I can just take a look at what the changes will be. So it compares state of what I used to have to what I'm going to have. And as you can see, it tells me this is what it's going to create. This is what it's changing in state. So it's saying, I'm going to create this hobbies bucket, and I plan to add one thing. I'm not going to change anything, and I'm not going to destroy anything. And so if we run apply now, when apply, it will prompt me saying, hey, this is what you're going to change. Would you like to accept these changes? I just say yes or no. So as you can see there, I've responded with yes. And because of that, it's created now my bucket. So let's go into AWS. This is the AWS console. This is how Amazon S3 looks like. I'm looking at my buckets, and I'm searching for CODECON, which is what I called my bucket. As you can see there, I've got one bucket. But when I enter this bucket, unfortunately, it doesn't have any ducks because I've not added any ducks yet. So it's quite empty. So let's get into that. Let's go back into the Terraform code and add our ducks. All I've done now is I've uploaded a PNG of some ducklings, this little picture, and I've now defined my object. So I've said, hey, I want to create a resource, and that type of resource is an AWS S3 object. I can call it whatever I want, and that's just so that I can reference it anywhere, really, in the Terraform data. I'm calling the bucket, this is where I'm adding the object to. So I'm adding it to this ID, hobbies bucket ID. I've referenced it. I'm calling it ducklings, and this is the source of what data I want to upload. Again, same procedure. Apply, you can do plan, apply. The great thing about apply is it'll actually plan it for you, and it will ask you before. So I've just done that. It's told me that, hey, I'm going to create all of these. I've said yes. Go back to the console again. We have the ducklings. Great. And all of that was using code. Now, if you access this page, if you're so interested, you will find these ducklings. Cool. So that's a great example of sort of a manual process of adding or uploading an object into S3, but it's all done using code. And the great thing about that is now, if I wanted to add more hobbies, for example, if I wanted to add Steven's hobbies of a sprinkler, I can just do the same thing, maybe have a different environment for each hobby, and utilize that same code. And therefore, I don't have to waste time, that manual, laborious process of adding it through the console. Cool. So now, just like we've said, what are the benefits to IAC? So the first one is consistency and repeatability. IAC actually enables an organization to achieve these because we use the same code to configure and deploy the infrastructure across the different environments. This helps eliminate any risk of configuration drift, and it means that the infrastructure is always in a known state. Because it's in code, it's always in a known state. Secondly, IAC actually makes infrastructure a lot easier to manage at a small and a large scale by automating the provisioning, the deployment, and the management of the infrastructure. An organization can really reduce the time and effort that developers spend on creating all of this infrastructure, and that kind of leaves room to more ambitious projects. So an organization can take a big project at a high scale because everything is done through code rather than through that laborious manual process. Thirdly, IAC improves collaboration and agility within the teams. By using the code as the primary means of communicating infrastructure requirements, a team can work together more effectively, and changes can be made more quickly and with greater confidence. Finally, IAC enhances security and compliance. By using the code to define infrastructure, an organization can ensure the security and the requirement needs are met way ahead of time. Everything is done in code, so everything is very visible, and it doesn't have to be bolted on later on. Now, why Terraform? There are a bunch of different solutions that you can use for IAC. Why are we specifically talking about Terraform here? So the first thing is it supports a wide variety of different providers. This includes, as we've seen already, AWS, but you've got Azure, you've got Google Cloud Platforms, and you've got quite a few others. That means this allows a user to manage all of their infrastructure across multiple cloud platforms using the single tool, which is Terraform. Secondly, it uses a declarative syntax. This means that a developer only needs to define their desired state rather than the steps to achieve. And this kind of takes away all of that headache of breaking down what I need to do to get to this point. It's very simple, and visually, it's very easy to see what state everything is in. Thirdly, as we saw already, it uses a sort of plan and apply workflow. It allows users to preview the changes before and after. It kind of, just in case you're going to break down, shut down the entire platform, there's almost like a fail-safe for that. And finally, state management. As we've seen already, it adds a sort of like a state lock file, and that helps the user to see the infrastructure and make sure it matches the desired state. And it also allows Terraform to make like incremental changes and keep track of the changes over time because it's all version controlled. Cool, and that is Terraform and IAC in a nutshell. Very short, nice introduction. I hope that all makes sense. Thanks for listening.